In the last section, we saw that terminal points are determined by angles. We'll now introduce the idea of a reference number, and this is going to be a number that makes a minimal path between a terminal point and the x-axis that lies on the unit circle. In this picture, our number would be represented by the length of this arc. If you remember the definition of radians, then the length of this arc is going to be the angle in radians of this red theta here. We call it theta bar. Using the reference number, we'll be able to find terminal points in a more exact manner. Let's look at the definition of a reference number. Here we have our definition, and to start off, let theta be a real number. Then the reference number, theta bar, is the shortest distance along the unit circle between the terminal point determined by theta and the x-axis. Again, this means that theta bar is an angle given to us in radians. Let's now use reference numbers to find terminal points. We'll first describe a method and how to do this. This method is an update of the previous method only in terms of language. First, suppose we're given a terminal point that's determined by an angle theta. Then we need to find the reference number theta bar. Once we have our reference number, we're going to find the terminal point Q that's determined by this reference number. In the last step, we find the xy values of the terminal point P. These will be the same xy values of the terminal point Q that may differ by a plus or minus sign depending on the quadrant. Let's use this method to find a few more terminal points. Before that, let's practice finding reference numbers. Example 4, we'll find the reference numbers for the following angles. In part A, the angle given is 5 pi divided by 6. In B, we'll be looking at theta is equal to 7 pi divided by 4. And in C, we'll be looking at theta is equal to negative 2 pi divided by 3. In each case, we'll draw the unit circle and find the reference number there. Let's start with part A. Here we have our unit circle. Let's go ahead and draw the angle, 5 pi divided by 6. 5 pi divided by 6 is greater than pi divided by 2, but less than pi. So the ray of our angle is going to be in the second quadrant. Here's our terminal point. Then the reference number is going to be given by this angle here, theta bar. And to determine this angle, we'll just go ahead and subtract 5 pi divided by 6 into pi. And what we're left with is that this is going to be pi divided by 6, and this is our reference angle. Again, we'll look at the same process in part B. We'll start with our unit circle. Then we'll draw the angle, theta. So 7 pi divided by 4. This angle is larger than pi, but less than 2 pi. And clearly 7 pi divided by 4 is larger than 3 pi divided by 2, because if we change the denominator of 3 pi divided by 2, we'll get 6 pi divided by 4. This means that this angle is going to lie, the terminal point is going to lie in the fourth quadrant determined by this angle theta. Then the reference number is going to be the angle between the angle determined by this theta bar here. To find theta bar, this will be equal to a 2 pi minus our 7 pi divided by 4, which is just equal to pi divided by 4. In the last example, we have an angle in the negative direction. Negative 2 pi divided by 3. Again, this is larger than a negative pi, so it's going to be in the third quadrant. then our reference number is going to correspond to this arc length, which is the same as this angle here. To find theta bar, we're going to take our negative pi and subtract by a negative 2 pi divided by 3. What we're left with is a negative pi divided by 3. Now that we can find reference numbers, let's use this to find terminal points. Example number 5. Find the reference value for theta and the terminal point determined by theta. And we'll be doing this for two different theta values. In part A, we'll be looking at theta is equal to 11 pi divided by 6. And in part B, we'll be looking at theta is equal to 17 pi divided by 6. So for part A, we'll draw a unit circle. And first, let's draw the angle 11 pi divided by 6. 11 pi divided by 6 is less than 2 pi, but it's greater than 3 pi divided by 2, which means that our terminal point is going to lie in the fourth quadrant. Our reference number, theta bar, is going to be then 2 pi minus 11 pi divided by 6, which leaves us with pi divided by 6. The terminal point determined by pi divided by 6 lives in the very first quadrant. And it has values of square root of 3 divided by 2 and 1/2. Since the terminal point divided by 11 pi divided by 6 is going to have the same x, y values with the exception of the sign, we see then that the terminal point determined by 11 pi divided by 6 is going to have a square root of 3 divided by 2 and a negative 1/2 since we're in the fourth quadrant. And this is going to be our answer for number 1, part A. Then in part B, let's go ahead and draw our picture again. Here we have our unit circle, and this time the angle we're given is, this should be a 17 pi. So 17 pi is larger than 2 pi, which means we go around our unit circle once, and we're left with another 5 pi divided by 6. So this angle is coterminal with 5 pi divided by 6. Therefore, the reference number is given to us by pi minus 5 pi divided by 6, which is going to be pi divided by 6 again. The point then determined by the angle pi divided by 6 again has x value square root of 3 divided by 2 and y value 1/2. Then the point that we're looking for, whose angle is determined by 17 pi divided by 6, this terminal point here, is again, it's going to have the same xy values of our red point with a change of sign possibly. This will have a negative square root of 3 divided by 2, comma 1/2. And this is going to be the answer for part B.